So, quantum mechanics is difficult, and we don't really understand all of it in this class. We have its consequences. The simplification process of particle physics continues when we look inside the atomic nucleus. So where are we at this point? At this point, the whole structure of the universe is described by 100 or so odd species of nuclei, and the existence of a particle called the electron. So if you have a nucleus that has an electric charge Z, put it around where electrons are, it will attract Z electrons, because at that point it becomes neutral and does not attract any more electrons. Those electrons will arrange themselves according to the rules of the Pauli exclusion principle in appropriate Schrödinger wave functions around the nucleus, and then it can interact with light, which in some sense is a particle known as a photon. So we have 100 odd and two other kinds of particle. When we look inside the nucleus, we find more structure and more simplification. So what do we know inside the nucleus? Well, what is discovered is that the mass of a nucleus, well, what is again your guess for a nucleus? Your guess for a nucleus would be a positive charge, small compact object whose mass is an integer multiple of the mass of a hydrogen atom nucleus, because the mass of a hydrogen atom, as we said, and the mass of a hydrogen nucleus are about the same. So you could have a hydrogen nuclei in the nucleus, but that doesn't make sense, because the charge of a nucleus is only Z, and the atomic number of a nucleus or an atom on average is about half its atomic mass. So what the guess is that there are Z atomic hydrogen nuclei, as Rutherford calls them, inside the nucleus, and then the rest of the mass is some neutral stuff, and nobody knows what that is until in 1932, the discovery of another species of particle called a neutron, because it carries no charge. Its mass is almost identical to that of the proton, and a nucleus, it is discovered, is composed of Z positive protons and A minus Z neutral neutrons for a total mass of A times the mass of a proton and a total charge of Z times the charge of a proton. So now we have a way of constructing nuclei from their fundamental building blocks, protons and neutrons. We also have, as a consequence of this, an understanding of a puzzle that was the existence of atoms with the same charge, the same chemistry, but different mass. And these are called isotopes. They're chemically indistinguishable because with the same charge, the nucleus creates the same electron cloud around it, but with different numbers of neutrons, the total mass of the nucleus is different. So you can have several species, for example, of helium. This also explains why atomic masses were not precisely integer combinations, integer multiples of the mass of a hydrogen atom or a hydrogen nucleus. The reason for this is that in nature, when we, for example, measure the mass of an atom of hydrogen, we are mostly measuring the mass of the fundamental hydrogen atom with one proton in the nucleus, but there is a species of hydrogen, an isotope of hydrogen called deuterium, which has a neutron and a proton that has twice the mass of a hydrogen atom approximately, but the same chemistry as hydrogen. And so when we measure the average mass of a hydrogen atom, we measure mostly atoms with one proton, but some atoms, a small fraction of the hydrogen in the world, has double the mass, and so the atomic mass of hydrogen is a little bit higher than the mass of the proton and electron. But we have a huge simplification. Remember, we went from millions of chemical compounds down to a hundred or so elements, and then 100 or so nuclei surrounded by electrons, and now we're down to 3 fundamental particles: protons, neutrons, electrons. You can include photons for a table of the particles of the universe. The entire universe is made out of these 4 heroes. We have here their particles, their mass, and their charge. Protons have positive charge, neutrons 0, electrons are negatively charged, and photons are neutral. We have their mass, units in which the proton has mass 1, the neutron has approximately the same mass, and an electron has a mass which is about 1,000th that of a proton or a neutron. And the photon, for reasons that will become clear later, is a massless particle. This is it. This is all you need to describe everything from the hydrogen atom to DNA to you and me is made out of these 3 particles. There is a lot of structure. There are a lot of laws of nature to learn, but we have condensed the fundamental building blocks of the universe to a very manageable table. This is the situation in the first third of the 20th century. Life gets, as we will see later, more complicated when you drill down into the details. But for now, let us take stock of progress that we have made. We started 2 weeks ago from the understanding that the retrograde motion of the planets didn't quite fit in naturally to a Ptolemaic model of the universe, and we have followed a few centuries of physics through dramatic discoveries that have led to a collection of unifying, universal laws of nature that allow us to understand all of the the right-hand side of Newton's equation. The forms of matter are right here in front of us. There are protons, neutrons, and electrons. All of the interactions, they include the electromagnetic interactions, characterized here by the photon. They include gravitation, which is described very aptly by Newton's law. We have this complicated quantum theory that describes microscopic particles. We have come a long way. It has probably felt like a lot more physics than some of you may have signed on for in taking a class in introductory astronomy. All I can say is, there will be more. So, don't give up on physics yet, but also none of what we have discussed has been for the hell of it. All of it will actually be useful in understanding the astronomical objects that we are going to be discussing. And after a well-earned break of a week, we will come back and we will start applying all of this great knowledge to understanding aspects of the universe, starting with our local neighborhood, the solar system. Enjoy your break.